All right. So what we're looking at is quadratic functions, vertex form, and the big thing is with this one, what makes a quadratic function is that x squared is your highest power that you're looking at. Now, the good, and again, we can look at this a couple different ways. They may give it to you as an equation where it's y equals x squared. It may also be a function where it's f of x equals x squared. It doesn't matter how it's written, it's still basically the same thing. So it doesn't matter whether it's y equals or f of x equals, because every quadratic function we do is a function, so we don't really have to worry about the whole function connotation. So whether it's y equals or f of x equals, it's still going to be the same thing. All right, so here's the big difference when we're doing these. If we want to do this, and we really only do this on this one problem as we do this one, but basically, if we just start to sketch some of a few numbers here, and we're not going to be able to sketch a whole lot because once we get too big on the numbers, it goes off the charts pretty quick. But if we had, x equals 2, y would equal 2 squared, so y would equal 4. If your x was 1, that's 1 squared, which is still just 1, so that would be at 1, 1. You do 0. 0 squared equals 0, so it puts us at 0, 0. And if we go negatives, what happens when you square it? Now, here's where, again, where you got to kind of really be careful with these. When you're plugging in negative numbers, make sure you wrap that number in parentheses. So it's negative 1 squared, so that would make it a positive 1. And same thing if we do negative 2, that's negative 2 squared, which would equal 4. Okay. Now, and we're not going to graph. Now, we could get to where we could graph, we could talk about 3 and negative 3. But here's kind of the big thing with quadratics if you're doing this one. If it's just x squared that we're talking about, which sometimes they'll call it the parent function when we're going through this thing. Whether the number's positive or negative, if you square that number, it's always going to be the same. So whether it's positive 1 or negative 1, it's still just that number squared, so it's going to be at 1. 0, of course, is 0, so it's kind of stuck. So whether we did 3 or negative 3, if we did negative 3, it would be negative 3 squared would equal 9. But if we did positive 3, it would also be, that number. So that it's got symmetry. If you want to kind of think about it that way, it's got the mirror images, so everything's kind of, the same as we're going through these. Here's the big thing when we're doing this. And again, I'm not going to ask you to use this table and graph these because this is really slowing things down. That when we're graphing these, it's basically going to be one of those things where you're going to be able just to do a quick sketch of a graph. Like you're going to be able to graph it in like 5 seconds. Or should be able to. Something pretty close to it. Okay, so if we go back and graph it, we've got 0, 0. We've got 1, 1. We've got negative 1, 1. We had 2, 4. We had negative 2, 4. And again, we're not going to worry about doing these because we know that eventually 3, 9 is going to be up here. We're just going to keep squaring the numbers. So we're going to have, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 30. So the numbers are going to grow really fast. So there's no way we're going to be able to get those on a graph. So we're just going to graph a few of these just so we make sure we got it here. All right, so when we did absolute value was a V-shaped graph that was at 0, 0. We were just looking at like that part of it. Parabolas, when we do x squared, it's a parabola. It's a U-shaped graph. So the shape is going to be a parabola. The St. Louis arch is the best version of it. Now, again, it's going the other way, but it's still a parabola. It's still got that same basic shape to it. All right, and a couple of things that you've got to kind of get from this one. Whenever you have the top or the bottom of the graph right here, this point that's at the bottom of the graph, or if we were doing the St. Louis arch, it'd be at the top of the graph. That point that's at the bottom or top of the graph, they call that the vertex. So it's the top or bottom point of the graph. Yeah. So for us back here, our vertex for this one was at 0, 0. All right. And then the other thing we're going to talk about is an axis of symmetry. And the axis of symmetry is basically this. It's a line. Let's just say it this way. It's a vertical line. That is drawn through the vertex. That cuts the graph into equal halves. Okay. And when you're graphing these on Math Excel, sometimes they ask for the axis of symmetry, sometimes they don't. It just some problems they do. Just kind of depends on which one they're going for. But if they ask you to draw a line of symmetry, most of the time when they do this, all you're going to do is you're going to go back to your graph that you have, and you would draw an axis. You draw a vertical line that's dashed that would go right through the too far. They go right through the middle of the vertex. Right, now it's hard to see it when it's right on the y-axis, just because of how it is there. But basically we've got something like that. All right, and here's basically what that does, and here's what it's saying when you get through this part, is that if you were just to graph this half, because some people don't like doing negative numbers, but if you know what your vertex is, every point that you've got, if you plug in your positive numbers, if you kind of stretch this thing out where you're 1 point this way from the axis of symmetry, for this point, you could also find another point over here that would also be 1 point away. Or 1 space away, 1 unit away. When we did this point, it's 2 units this way. So you also could draw a line that would go 2 units this way, and that would give us this point that would be here. And that's what the axis of symmetry is doing. So if we went back up here and we found another point that was 3 spaces over, that was here, sorry, if we found another one that was 3 spaces this way, then according to axis of symmetry, you could draw 3 spaces this way and put another point here, and then you connect those points. So you can just keep extending this graph out. So when you're doing the x squared, you don't really have to do both sides of it. You can do one side of the graph, and then every point that you use on this side of the graph, you can just equally space it out to the other side and draw it so it fits perfectly with what you're going to do. So you really only have to work to draw the whole entire graph, because everything over here is going to be the same as everything over here. But you can just It's a mirror basically is what it is. You got a mirror that runs down this way, and it's a reflection from one side to the other. There. All right, now here's the thing when you do this one. When you do the axis of symmetry, if you draw a vertical line, now and again, sometimes zero it's hard to do that, but let's say we drew a vertical line that was over here to hit the x-axis at 2 or something like that. What's the equation of a vertical line? Is it x equals or is it y equals? It's x equals, right? So if you're drawing, because if you think about, again, we scooted over here where we're talking about like x at this point, every point along this axis is 2. Every point along this line is at 0. So it's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So when you talk about an axis of symmetry, the axis of symmetry equation is always going to be x equals basically it's an x equals a constant. And every book kind of labels it different when you go through this. And we're just going to say basically it's x equals, and it's the x value of the vertex. So for this one, this axis of symmetry would have been x equals 0. And sometimes on these, if you want to put just AOS for short, then we'll do that just so we don't have to keep writing out a bunch of things when we do this one. So the axis of symmetry for that particular graph would be at x equals 0. Okay. So there's two, and again, I don't know if y'all, again, where y'all were in COVID with everything that happened 2 years ago. I don't know if y'all would have gotten that knowledge from one. Maybe not. Just depends on where you were, or who you were with. You know, if you haven't seen that, then we're just adding in some details to some graphs on these. All right, now for this part of it, here's where we're going to start graphing these. But again, when we graph these, you're not going to have to make a chart like this, and you're not going to have to plug in 15 points and plot each one of these things. We're going to give you a shortcut where you should be able to graph this one by hand in like 5-10 seconds without knowing hardly anything at all about the graph. But even without knowing anything, you know like a lot about the graph when it comes down to it. So. We're going to try to keep this as simple as we can when we go through this thing. So to graph quadratic equations, the very first thing is we're going to do is we're going to plot the vertex. Okay, and it's going to be really easy to find the vertex when we do these, and we'll show you how to do that here in just a little bit. And then after that one, you need to plug in, the fancy word for that is evaluate. An x value near the vertex. To find another point on the graph. Okay. And once we can find that, once we've got the vertex and we've got that one other point, if that point's on the right side of the graph, and we know that the right side looks like this, then we're just going to say, okay, if this is one space this way, I can move one space this way. This is two spaces this way, and then we can go back and draw this thing in. So it's not going to be one of those things where you, back in the old days where you had to graph, plot the tables and plug in 7 different points. No, we're not going to do all that. This is basically, we're going to make this thing short and easy because you can get a lot of information just from a couple of points by looking at the equation for what's going on with this thing. All right, now here's a trick that we found for this one. And this only works for whole numbers. If the coefficient, remember that's just the number that's in front. If the coefficient, if the number in front of x is a whole number, you can treat that number like slope to get the next number. Or to get to the next point. Now, again, it only gets you to the next point. It only works for one point, which if you're going to use Math Excel most of the time, or if we're doing a test, that's really all we're worried about. If you can get one point on the graph, then on Math Excel, it will then draw the entire graph for you. Okay, now, and the key thing is, it's only the next point. It doesn't work for anything after the next point that's right beside the vertex. It doesn't work for, two points away or 2 units away or 3 units away. It only works for 1 unit away, based on whatever that whole number is going to be. Fractions, it does not work. So we were doing this one year. We were trying to use this shortcut, and we were doing some stuff, and we did some fractions, and we did it. And we were like, hey, that didn't work. And we were like, So we tested a few more fractions and found out if it's a fraction, it doesn't work. It only works if it's a whole number that's beside as your coefficient for this thing to actually work out to be what it's going to be. Okay, so here's what we're going to do. Here's how we kind of put all this together. And every book calls it something a little bit different, but we're going to say this is the graphing or the vertex form of quadratics. Okay, and it's y equals a times x minus h squared plus k. And again, this is one of those things, if they give you a graph like this is something that you should be able to graph an equation in 5-10 seconds without plotting in 10 million points. And again, we can use our shortcut, we'll be okay. So here's what we're looking for. The a value, shoot that down a little bit. The a value tells the direction of the graph. And again, this is where we're kind of going back and borrowing some stuff that we had from back in the last chapter. And this is where we dig into a little bit more. That basically is this. If a is greater than 0, if a is positive, we would say the graph points, but that's not like, some teachers get really mad if you say the graph points. We'll just say the graph opens upward. So if you say, again, they say it opens upward, you can say it points upward, whatever you want to do for that part of it. Basically, here's what it looks like. If a is greater than 0, if it's positive, you're going to have a graph that will look something like this. And I always try to tell people, think about what the arrows are doing. If you think about where your positive numbers are, they would go up the y-axis. So in this case, these things would point as you're going up the y-axis. Where if a is less than 0, if a is negative, the graph opens down. And it sounds funny to say that a graph opens downward because it doesn't make sense that it's open as it goes down. But that's what the technical mathematical part is. And again, it points. Some teachers will get mad if you say that it points down. Some of them don't care. It just depends on, how much of a stickler you are for these. So if you have a graph that's got a negative a value, the graph will always look like that. Okay, so if you look at a problem, a value tells you which way it's going, so you know the basic shape of the graph, whether it's going like upward or if it's going down. The other thing you can get just by looking at it is that the h and the k numbers you have here, the h and k, well, that's your vertex. So you can actually like just look at something and see what the vertex is. It's kind of like your parents when they walk in your room, they go, "But this thing is nasty. Would you just look at your room?" And you've been sitting in it all day. And you're like, "Yeah." So it's the same thing on this one. You can just look at it and see what it is. You don't have to do anything to it. You just look at it and go, "Okay, there's where my vertex is." And if you've got your vertex and you know if this number is positive or negative, you know the basic shape of the graph, and you can graph this thing sometimes in like 5-10 seconds. And that's what we're going to do today is we're going to show you the easy way to graph this thing. Tomorrow we show you what happens when it's not like this, but today it should be kind of easy as we go through this thing. Okay, now a couple of things you can get for this one. When we're graphing these, if the a value is greater than 0, if the a value is positive, we know the graph looks something like this. And if your graph looks something like this, where's your vertex in that case? Top or bottom of the graph? Vertex is at the bottom, right? So the vertex is at the bottom. And if the vertex is at the bottom, that means they're going to ask you what kind of point is that. Then that means the vertex is at the bottom, so it is a minimum point. Because they're going to ask you, okay, find the vertex. You can tell me what it is, and they're going to ask you, all right, is that a maximum point or is that a minimum point? And so from there, it's just figuring out, okay, is it at the top of the graph or is it at the bottom of the graph? If it's at the bottom, it's a minimum point. Okay. For this part, this is going to be running a little bit of room here. All right, so for this one, here's what you can kind of get as we go through this thing. Because it's the minimum point, it's at the bottom. You can talk about the domain, and you can talk about the range in this case. All right, and because it's a function, every single number, any function that we do, every single time, the domain is always going to be negative infinity to infinity. For the range, it's going to be this. It's basically for the range part of it, is you're going to be working with whatever the k value is. And then from there, it's going up to infinity. So from that part of it, we're going from k up to infinity. Now, and sometimes I forget with Math Excel sometimes it will do this, and I forget exactly how they kind of run this. Sometimes instead of doing k to infinity, here's another kind of easier way to kind of think about this. And if we're doing these on tests and it's paper pencil, you can kind of do either option for this one. The other thing they may also do, instead of doing the range like this, they may also tell you that for the range, that's your y values. Just tell me, okay, what's happening here? Our y's it's pointed upright, so the y's are getting bigger. So the y's are going to be greater than or equal to whatever your k value is. You're welcome. All right, and then your minimum value then is going to be k. So they ask you what's the max value, because sometimes they'll ask you what is the max value, what is the absolute biggest number or smallest number you can get to. It's whatever the k value is on the vertex. Because again, with domain and range, if you're talking about the x values, there is no maximum, there is no minimum. So there's nothing we can talk about domain because there's nothing, because it goes from infinity to negative infinity. So there's no need looking at that one. But your y values, there's going to be a definite low point or a definite high point just based on which way this thing is going to go. All right, and then basically everything is going to be the opposite for if you've got a negative number, if your a is less than 0. Because if that's a negative number, the graph looks something like that. And if you do that, the vertex is now at the top. So vertex is at the top, which means it is a max point. Right. And the domain will never change because, again, it doesn't matter what you do. You can go forever to the left. You can go forever to the right side of it. So your domain in that case is negative infinity to infinity. All right, for your range, though, which way do we go forever? Do we go forever up or forever down? Go forever down, right? So there is no low point on the graph because we go forever down. But now when we get here, this is the top, this is the max. So whatever this number is, that's your biggest number. So that's going to be the top of the graph or the end of your range for that part of it. Okay. And again, they may not give it to you this way. They may tell you to write it as an inequality. If you do, the y values are going down because, again, the arrows are pointing down. So this thing is going down. So everything here has got to be less than whatever your k value is. So the max value equals k. Okay. So a lot of words, a lot of talking. Here's where we actually like give you some numbers, and we're going to show you how quick and how easy you can graph some of these things once they give you an equation that's set up here. Everybody good there? Everybody caught up? Anybody still writing that down? All right. Here we go. Here's where we put it to practice. So we're going to do all these things we've done so far. We're going to find the vertex. Again, just for abbreviations, we're going to say AOS for axis of symmetry. We're going to find the domain. We're going to find the range, the max or min value, and they should kind of give you a button where you can toggle back and forth on that one. You know, some of them it's max, some of them it's min, wherever you're going through this one. And then you're going to sketch the graph. Okay. And again, we're going to do all this without, here's the crazy thing on this one. You're going to do all this without doing any math, which seems weird in the Algebra 2 class, but this doesn't require any math. Treat question. No? Okay. So this is no math. If that makes any sense at all, which doesn't. Okay, so it's f of x equals x minus 2 squared plus 3. All right, and here's what we're going to do. Anytime we're working on these problems, if you're stuck on something and we're going through these, the very first thing I'm going to ask you is, okay, what is your a value? What number is in front of x? Well, there's nothing there, but if there's nothing there, then that means that a value would assume to be 1, right? Because technically there's a 1 you could put in front of the x, so your a value would be 1. And then whatever numbers you have back here, this is your h. H is always on the inside of the parentheses. The k is always on the outside. And if y'all think back to absolute value, if this had been absolute value, this number told us how much to move horizontally. So that's the h part of it. This would be how much it would move vertically. Why that's not v, I don't know. That would make a whole lot more sense if that was a v and not a k, but nobody asked me, and that's just what they said. But to me, that would make sense. The h is your horizontal movement. This number should be v, where it's your vertical movement. If we did that, that would make a whole lot more sense, but they don't. So, but anyway. All right, now, what was the catch when we did this? When we did the horizontal movement, what did we know about it? Which direction did it go? It went in the went opposite direction, right? So normally we would think this was going to the left, but we said on the inside it actually goes to the right, goes to positive 2. So when you name your vertex, you've got to still do the same thing. Even though that's a negative 2, you got to tell me we're going to move this thing 2 spaces to the right, so this is going to be at positive 2. So your vertex would then be at 2, 3. So that part of it is still the exact same thing we were doing on the last test, that whatever number you got on the inside, you still have to change that and move it in the opposite direction. So if it's a negative 2 on the inside, you got to make it a positive 2 when you take it on the outside. The k value stays the same because that was kind of what we were saying for that. All right, now, is it okay that the a value is a whole number? All right, again, if that's a whole number, you can treat this like slope to think that that's 1 over 1. So when we're graphing this thing, again, you don't have to make it like a perfect graph, just as long as you've got a fairly straight line here. We're going to go to 1, 2, 1, 2, 3. So we're going over 2 and then up 3 to push a point right here. And that's our vertex. And again, as long as this a value is a whole number, you can always just do this number over 1 to kind of cheat and get to the next point. So from here, we can go up 1 and over 1 to get our next point that would be right there. And the good thing about with it being the vertex is if you go up 1 and right 1 to get this point, you can also go up 1 and then left 1 to get this point. So these points would be 1 space apart from the axis of symmetry. And this thing's just going to do a nice little U-shaped curve that's going to go like this. And it's going to go like that. There you go. And you graphed it in 10 seconds. Without any math at all. That's my kind of math. No math involved. All right. So now here's what we got to do a little bit of labeling. Again, if they ask you to draw an axis of symmetry, you're going to go back and draw a vertical line right down through the middle of the vertex. And if you do that, again, you're hitting the x-axis at 2, so you tell me that that's x equals 2, and that's your axis of symmetry. All right, so back up here, we've got the vertex. Got that right here. We've got the axis of symmetry. You got to tell me what the domain and the range are. The domain is easy because the domain is always, doesn't matter what the graph is, it's always negative infinity to infinity if it's x squared. Every single time. That part never changes. All right, the range, again, we said that's going to be your k value. This thing is going up. So this starts at 3 and it goes up. So it's going to go from 3 up to infinity. All right, now again, sometimes they don't do it that way. Sometimes and a lot of times they won't even give you the domain because they kind of get to the point of going, all right, it's always going to be infinity to infinity. So they didn't worry about giving you the domain. A lot of times they're going to ask you about the range. They may not do it this way. The other thing they may also do for this is, again, give it to you as an inequality. So again, this one is y, still your y value that's here, and that's going up. So this should be y greater than or equal to 3. And I don't remember, sometimes they let you do it this way, sometimes it's this way. So just kind of be comfortable going either way there. Test wise, if it's a fill in the blank question, which this one probably will be paper pencil, this one you can write it either way and I'm fine. It doesn't really matter. All right, let's see what. Oh, we didn't do max or min. Okay, so vertex at the bottom or the top? Vertex at the bottom, that means the vertex is a minimum point. And again, if they ask you for the min value, it's still this exact same number that you're using for your range, which is the same number that's the y value vertex. The min value is 3. So once you find your vertex, which is always the second number that's on the outside of parentheses, that's also your max or your min value, which is also the number you're going to use inside your range. So you just keep using that vertex value over and over and over and over and over whenever you're doing anything else with this kind of problem. The only thing you're going to use the x value for is to know what your axis of symmetry is. Okay, so to get everything, we've got vertex, axis of symmetry, domain and range. We stated that it was a minimum. The minimum value was at 3, and we sketched the graph, so we're going to go there. Okay. All right, is everybody okay with that? Again, no math involved. This is just look at it. This is a look at it kind of problem where you don't have to do any math at all. All right, let's do something where you gotta think a little bit. All right, so number 2, let's do y equals x plus 4 squared. All right, so we got to figure out what a and h and k are. Again, there's no number in front of the x, so that means the a value is 1. H value, that's the number that's on the inside. The k value, that's the number that's on the outside. And again, the number on the inside, it always goes the opposite direction we think. So for this one, we name it, we got to change the sign, make it -4. And there's nothing back here, right? So k value 0. All right, so there's our vertex. The other thing we know with a value being positive, we know this graph has to do this. And we'll worry about the specifics of exactly where that is in a second. But if that a number is positive, we know the graph has to look like this, no matter what we do. That was a terrible line, by the way. Okay, so we know we're going to go to -4, 0, put a point there. That's where vertex is going to be. And again, as long as the a value is a whole number, which it is, it's 1, you can do a shortcut and just go up 1, over 1 to get the next point that's here. And if you go up 1, over 1 to get the point to the right side of it, again, this thing, there's your axis of symmetry. So if we drew an axis of symmetry through it, everything has to be equally spaced out. So if this is one space this way, we also have to go one space that way to get another point there. We'd have a graph that looks something like that. All right, so the axis of symmetry is just the x number from your vertex. So that's x equals -4. Domain and range. Again, domain is easy because it's always -infinity to infinity. All right, the range is basically your y value, and you're either going to go up to infinity or you're going to go down to -infinity based on which way this thing is going. It's going up, so we're going to start at 0, and we're going to go up to +infinity. If we're doing inequalities on that one, that would be y greater than or equal to 0. All right, so we've got vertex, we've got the axis of symmetry, we've got domain and range, we've got the graph. Oh, we just got to do the max and min. So we've got the vertex here, vertex at the bottom, right? So it's a minimum point. And then the min value. Because again, domain, there is no maximum, there is no minimum. So for that one, you're always looking back to the y values. In that case, your minimum value would equal 0. No, we didn't even negative. Let's go with negative. Or before we do that, any thoughts, any questions, any what ifs on that one? So far, so good. All right, still doing the same thing on these. So not changing anything up. Let's make this f of x equals -2 times x plus 1 squared minus 3. Okay. Again, we'll take it kind of one little piece before we even worry about the vertex. We're going to worry about the a value. A value is -2. If the a value is -2, we know the graph has to point down because it's got to go towards the negative. So it's going to go this way, which means the vertex would be at the top, which means that's going to be a maximum point. Right. That also knows that if this is pointed down, your range has to be y less than or equal to whatever the k value is, which we'll go back and find in a minute. Again, domain doesn't matter because, again, it's always -infinity to infinity. Okay, so you can get that just from the first point. From the a value, you can know whether the vertex is at the top or the bottom. You know what the shape of the graph is. And based on what the shape of the graph is, you know whether the vertex is going to be at the top or the bottom. And if it's at the top, it's a max, which then means the range has to, everything, once you get to the top, there's only one way to go from the top, right? That has to go down. So that means the y values have to go y less than, because you're at the top of the graph. There's only one way to go, and that's down. Okay. Now the other stuff back over here is where we use those two values behind it to get in the rest of it too. So okay. So for the rest of it, pull out these two numbers for the h and the k. Again, change this number from +1 to -1. This one stays the same. I guess k in that case stands for keep it the same. Don't change it. But to me, I still think H and V would make a lot more sense. This is the horizontal movement. This is the vertical movement. Okay, and once you've got this number, now you know what the range is. That's your -3. So this number for your k value is always going to be your range because that's your y value. So you tell me, all right, what's the y value over here? It's -3. So we've got domain and range. Axis of symmetry is the x value. So whatever this number is, that's your axis of symmetry. Whatever your y value is, that's your minimum point or your maximum point. In this case, we said this was the maximum. So the max value is -3. And then the only thing left to do is just to graph it. We're going to -1, -3, so we need more room at the bottom here. Okay, so we're going to go to -1, -3. So -1, -3 puts us right here. And again, that whole number with a value makes this thing nice because when we go to graph it, we get to do a shortcut. Now, it's not the mathematical thing to do, but that's okay because we're just trying to graph this thing with the least amount of work without having to do any math. We're going to go down 2 and then over 1. And it doesn't matter which way you go because it's a parabola. Whether you go down 2 into the right or down 2 into the left, it doesn't matter because it's going to match this thing up either way you go. Okay. If they add, and again, 50-50 on these. Sometimes they ask you for the axis of symmetry. Sometimes they don't. This one, we're not going to do it because sometimes they don't ask you to. So, all right, last one. Worst case scenario. And the only worst case scenario on this one is the graph, and it's not even really getting the vertex, it's getting the next point on the graph. It's going to make this one a little bit tougher. All right, so the a value is 1/2. And again, we're going to use that to kind of get all the stuff we can get from it. It's still positive, so we know the graph is going to go up. So it's something like that. Puts the vertex at the bottom, so the vertex is a minimum point. We talk about domain and range. Again, I think in some cases they still won't even ask you for the domain because it's always negative infinity to infinity. It never changes. All right, the range in this case is going up, so it's going to start at something and go up to infinity. We just got to use our numbers to figure out what that number is going to be back over here. And again, we're going to get that number from what's on the outside. So that's going to be this number. So that's going to go from 1 up to infinity. So for the HK value, you can change this number because it's got to go opposite way from what it says. So we're going to go to -2, 1 for the vertex. All right, axis of symmetry, that's just the x value. We just said it was a minimum, so we know that it's going to have a min value of the y value here. That's going to be 1. All right, so we've got vertex, axis of symmetry, the max or the min value. We've got domain and range. The only thing left to do is to sketch this thing. Now, here's the catch for this one. We cannot use the shortcut that we did a minute ago because if you go up 1 over 2, that is not the correct place to get the next number. It just doesn't work with fractions because when you're squaring fractions, it just doesn't work out to be the same way. The fraction is what those whole numbers, it's fine. And again, these are only getting, it only works for 1 point. If we were graphing these back up here a second ago, this point was -2 over 1. that only gets you to the next point. To get to the next point down here, it's down like 5 or 6 and then over 1 if we're going to graph this line. So when we're doing this one, this only works for the one point that's the next point on the graph. It does not work for any other point after that. So like if we were graphing these, I think the next point here would wind up being at, let's see, where was this next point going to be? It's 1, 2. It's like at negative. I don't know what this is going to be. Is it 1, 2 squared? This wound up being like at 4, like at 1, negative 11. So this was down 2 over 1. The next point was down 6 over 1 or something like that. So it again, this shortcut only works for the next point. If you want another point after that, you have to actually like plug it back in and see what that next point's going to be, because that's the only way you can kind of get through those. All right, so for this one, you have to find another point. The shortcut doesn't work, so what we're going to do is now the only thing we can do for this one is we're at negative 2, 1. So let's go ahead and do this. So we got negative 2, 1. So we know this is going to be our vertex that's here. All right, we do know it's going up this way. So eventually we're going to get here. And you've just got to pick points that will actually work out for this thing. And here's kind of what you have to do. Whatever this denominator is, you've got to kind of pick multiples of that denominator. So you could pick 2, 4, 6, 8, those kind of numbers, because if you pick a number that's 1 and then you square this thing and then try to divide it by 2, you're going to wind up with a decimal number, because it's going to be a half, but it's going to be an odd number divided by 2 because you're squaring it, the way it works out for that thing. So for these, whatever this number is, because you're going to divide it by 2, you want to basically pick even numbers. If this was like divided by 3, you want to pick multiples of 3 to make it work out for those. So whatever your denominator is, you want to kind of go with that one. Now, if you start working this way, so instead of going over 1 space, let's go over 2 spaces. So that would put us at 0. So you could almost kind of think about it this way, that this is how many spaces you kind of want to go over to get to the next point. So wherever this point is, if it's over 2, go over 2 points and plug in that number. If this was over 3, you probably want to go over 3 spaces and then tell me what that number is and plug it back in. So for this one, if it's over 2, we're going to go over 2 spaces to the right. That puts us at 0. So we're going to plug in 0 to make this work a little bit easier. So we're going to plug in 0 back into this equation that we had back up here. So that's 0 plus 2 squared, which is just 2 squared. 2 squared is 4. And here's why we picked that number, because then we're going to do half of 4. As long as that's an even number, that's easy to do. Half of 4 is 2. So that's 2 plus 1, that is 3. So the next point that's easy to graph on this graph is the point that's at 0, 3. So that would put us right there. All right, and again, if we drew an axis of symmetry, if this is 2 spaces this way to get this point from the axis of symmetry, we've got to go 2 spaces this way to get another point that would match up with it right there. Okay. And that's a worst case scenario. If it's a fraction for the a value, there's not really a shortcut. Well, there's a different shortcut. Whatever this denominator is, you're probably better off to move that many spaces. You can go to the right or to the left. Doesn't matter which one. But usually you want to go that many spaces over to get a number that when you plug it back in here would actually work out to be an easy number. Let me just show you if we'd only gone 1 step over. If we just go on to the next, some people are like, well, why not just pick the next number right beside it? This is negative 2. They were like, why not just pick negative 1? You don't have to write this down, but let's just show you what would happen if we'd pick negative 1. If we'd pick negative 1 and plugged it back in up here into this equation, we had half of negative 1 plus 2 squared plus 1. Negative 1 plus 2 squared is 1. When you square the 1, you get 1. You've got to take half of 1, which is a half. add that to the 1, that's 1.5. How are you going to graph that? You're just going to guess, right? But what if your guess is wrong? Then it's wrong, right? So that's where we're trying to stay away from fractions and decimals. So that's why we have to pick something that will kind of work out so that we'll do that. So if you get a fraction, again, just use that number to know how many spaces over it's going to go that one. If you think about these back here, if you make this a fraction, this tells you how many spaces to go over. You can go over 1, and you can find a number that would be easy to plug in.